Hello, everybody, and welcome to a new edition of Photon Insiders. We've been off for a while, with summer being around and a lot of projects being about to get shipped. But today, we're back with, you guessed it, a special postmortem for Battle Royale 200, which we just released for free on the asset store yesterday. I know a lot of you are very excited to dig into it and already have. Some even have playtested with us. But how many of you have more questions and, more importantly, would like to gain some insight as to how we got to the final product that you have seen today? Well, today are joining two awesome devs with me. We have Jiri Bury, our lead dev on BR200, and
Hi,
of
everyone.
course, Stary, who is the lead dev on Projectiles and worked heavily on the gameplay we have seen in BR200.
Hi, guys.
Right, so as we Photonians know, Fusion BR didn't start out as a shooter, at least not in the classical sense of the word. Jiri, do you want to give us a couple of insights as to what the original idea actually was?
Yeah, of course. So, well, the project started from scratch because the Photon Fusion was in very early stage of the development. So we were starting from scratch, basically iterated on a free playground. And the original idea was to have 200 players with the Viking team. So it was planned to have like bows, arrows, some sword battles, and yeah. So it was not planned as shooter originally. So yeah, that's the
story behind it all. So I know we do have a couple of pictures actually that allow you all to see a bit where we started from. Jirka, do you want to showcase a bit where we stood originally in terms of visual design with the various?
Yeah,
Well,
for sure.
icons?
I will be controlling the images, but Easy would have to make the initial talk because I wasn't in the project by the time.
Yes, so this is the first project setup, and the first thing we were implementing was the checking the lag compensation. So there was a server running, and this was actually a client view, and we were testing hits on the clients. You can see in front of the main character, so they were just moving in a circle, and we were just testing the lag compensated hits under certain network conditions, simulating lag and making sure that it works under any condition.
Any condition being, of course, the operative word here. Now, we even have a bit of gameplay here that we can show you from the very early tests we had with bow and arrow.
Yeah.
But of course, you know, at some point we figured let's move away from this concept that, although very popular at the time, we wanted to build something a bit more mainstream, more relatable in terms of gameplay. But of course, while gameplay is important, we are first and foremost engineers, and our goal was to, well, set a new standard with what could be built. And so, of course, you know, we thought, what are the couple of things that are the hardest in multiplayer, especially in state transfer? And that is fast-paced gameplay, high number counts, high player counts. So what was the result? Making a Battle Royale shooter. Now, we of course had this planned out, and what were kind of like the key technical targets that we had set for ourselves in order to really showcase how good it could be? Like, what was the nut that we were trying to crack, the bar that we were trying to reach?
Yeah, so the bar was set, or the goal was clear: 200 players, 60 hertz simulation on the dedicated server, and that's basically all we wanted to reach, and everything else was just a side goal.
So we just wanted to reach double the network tick rate than most AAA shooters with twice the amount of players. Yeah, you know, just a usual day at Photon, I suppose. So with this new project in mind, you know, we started out building stuff, and of course this brought us to some of the original playtests. But before we go down this particular road, we definitely want to talk a bit more about the other things that were core to this original prototype. So
So if I may, Tim, so
yeah.
After the introduction to the project, it was in a state of this Viking demo. They transferred basically to this third-person shooter, and soon after that, it's the time where I joined actually, and we started to bump some gameplay features. You can showcase, for example, how we started with the video. Could you make it online?
Yes, of course. My apologies. There we go.
No,
the other one.
The other one. Yeah.
There we go.
Yeah. So we started with the basics, right? With the shooting. Then we moved on. Let me upload this. It's clunky here. We moved on how to drop the weapon, to pickups and the usual stuffs, recoil patterns, and basically the basics what you can now play in the BR. So that was my initial weeks in the project. And back to Jiri.
Yeah, I think we can also still show some videos of the Viking village prototype. Okay, let me upload the video.
All right, I got it.
Okay, so I think we can play. So that was more stuff in the Viking. We were heavily iterating on our own character controller. So that was the first test, actually using the terrain system from Unity, colliders, colliding with regular meshes. So it has, you can see in the video, some jittering. So that was the early development, and we continued a lot on and iterated on the character controller later. So then, yeah, we decided to leave this Viking team and make the third-person shooter, which Jirka already shown you. So
yeah, sorry that we skipped this part. You need
I think I think this is quite interesting to show.
Yeah, of course.
And so we, of course, then as part of that, you mentioned a couple of topics that were key already, right? So we had lag compensation. We had, of course, the actual character controller. Now, if we actually speak about these two aspects, are well, the two of you have worked heavily on it. You, Jirka, on lag compensation as well, in terms of how it then evolved throughout the project and towards the projectile sample. But Jiri worked on the character controller, which, as you all know, became the actual KCC add-on that is currently being available. So if we take with, these fundamentals of player control, maybe starting with the character controller, what were the things that we needed to aim for in order for this to be, at the quality that we desired?
Yeah, so the core requirement for the KCC was performance, because no existing solution would match the performance we needed, no matter if it's Unity character controller or available solutions on the asset store. They are just too slow for the BR, so we had to develop our own solution. And in the end, it evolved, and we separated the controller from the BR project and started a separate KCC project, which is dedicated for character controllers. So you can see this is basically a setup which we are using for testing the character controller. So you can see there are a lot of stairs, a lot of different slopes we can go into and possibly test different scenarios. You can see some corridors and tunneling. Yeah. And let me show you another video.
All right, so let's move this out.
Yeah, so here you can see, okay,
the actual character.
yeah, you can see the actual character, which is colliding with so-called KCC processors, which somehow modify the behavior of the KCC. Here you can see it's a low gravity environment, low gravity with big jumps, so we can easily modify behavior of the KCC. It can be you can just take over the control of your character and, let's say, push it whenever you want. Yeah. And this is all available as a separate add-on for the Fusion.
This testing scene, is that part of the actual KCC sample?
Yes.
So there you have your answer, Stinky Steak. Yes, it is available. Just get the sample from a website and then you can play around with that.
Yeah, you can show my screen.
Yes.
Yeah, so this is basically the whole testing scene, and there are a lot of cases where you can test how the character behaves on many combinations of terrain, colliders, and whatever. So that's basically all to KCC.
That's it. You know, it being in quotes in this case. This was a whole lot of work. And then, you know, that is to control the character, which of course, as we know, is the fundamental part to, well, move and start your player experience. But there's of course the other part that is absolutely key for a shooter, and that is, well, the shooting, isn't it? Jirka, do you want to elaborate a bit on like the early steps we had in that area and how that evolved?
Yeah, for sure. So I already told something before, but let's recap. When I joined the project, there wasn't really much of a shooting from a weapon. So we started simply just by doing hit scan weapons with basic shooting with dispersion. Then we moved on to be able to pick up weapons, drop them, pick up other things like health packs and ammo. And we also worked on recoil patterns, recoil reduction. So pretty standard stuff that the shooters of modern age include. So that was the shooting part. Do you have some specific questions?
Well, I mean, the shooting, of course. I mean, this is how we build it in BR200, and BR200 has shooting in a way that it can actually afford the performance overhead required for 200 players shooting, right?
Yes.
So, what is there anything in particular as to how you had to approach, you know, the
so the bandwidth and the weight on if we can handle the performance of these things, we had to have it in mind. So we choose to do the hit scan weapons. It served us well. It is really responsible for the player, and on the other hand, it can be really optimized well. So the core of the BR200 are hit scan weapons. We use projectile data buffer, which I'm sure many users already know by now, because we have also another sample, as you mentioned, for that. Yeah, that's basically it. I'm not sure if I should go more into the implementation details. Probably not for this stream.
I mean, as far as you know, we're not doing a deep dive into code that is freely available to all of you, both from the projectile sample or the KCC add-on from our own website or the BR200 project over on the asset store. So I think, yes, we can definitely skip over that for now, but these high-level concepts are definitely important so that the code itself makes sense, right? We need to understand the architecture.
On the video that is currently playing, you can see that we also work on, for example, different effects when you hit different surfaces. And those were like early stages and are not really used in the current game because we have this blocky level that is more or less like concrete or something. But the support for these different surfaces is there, so it is just about setting it up.
And also, I mean, this is a perfect time to kind of move over to that other part that is key for, I mean, enable gameplay as well. And that is levels. we saw what it was originally, right? When in the game that was the Viking still, and of course we all know the actual levels that we have now, but you also probably remember playing these ones. So can you take us a bit through the iterative process of these early boxy level we saw to Viking through the ones that we have now in the final version?
Yes, so we started with the Assistor package, and this is a sample scene which we use. So we save our resources and just play in the environment which already exists. It's really nicely designed. We also used characters from the Assistor packages, and yeah, so that was our start. But it is not designed to handle 200 players. So in the end, we had to switch to something else. But for the start, it was really good. We were playing locally with up to 20 players, and that was like early internal testing.
So, I mean, you just mentioned the the overhead and that it wasn't made for 200 players, but at the same time, there's also the question of generating, like designing a map that is large enough for 200 players as well. I believe that part of the process has evolved throughout the actual development itself, hasn't it?
Yes, but it was at the later stage. This one is not good for 200 players because it's small, right?
Mhm.
So I
It
think
was small, and if I may, the environment is beautiful. We really liked it. And even though it is pre-set up, we had a lot of work involved with this map. Like we added the sounds of the birds and the ambience, and we added triggers on all of the water and mud surfaces. So when you stepped into the water, you actually heard the splash, and we have the footstep system that actually detects different surfaces. So we had different sound when you step into the mud, when you step into the water. So as a post-mortem, we must say that we probably already by this time should have known better than to invest time. But we wanted to have a nice demo, even in these early stages. And it eventually evolved as we will definitely speak about it further down the stream. But who played the current version knows that there are no such things like bot or anything. So basically, this all gets thrown away. So
yeah.
Well, you live and learn. I mean, if game development was easy, everybody would be doing it, right?
yeah, exactly.
Yes. Exactly.
So,
Right.
so early on, we this was a map where we tested like deathmatch and an elimination mode where you had certain amount of lives and then you ended up. But there was point in time where we needed to create a battle royale, right? It was called like that, so we needed battle royale, and for proper battle royale for so many players, we needed a larger map, and that's where Jiri started to work on.
Let me just play the video so
Yeah.
we can see how it was.
I mean,
It
this was
was-
a lovely map. It also brought
Yeah.
my older laptop to its knees every single time we played.
Yes.
Yeah.
But it was gorgeous.
There's also a lot of details on the ground, so it was actually one of the best use cases to test the KCC and to see what problems there are, because this is the real test for it. And in the playground level where everything is flat, there are simple box colliders or primitives. It's not that easy to to see all the problems which are connected with the character. You can see that the character is pushing in a wrong way. It's stopping a lot. So all this stuff needed to be fixed.
And this is also why, I mean, having this in a level geometry is fairly hard to debug. So the test level that we had, right, that we had earlier here, no, not this one, the
You mean these?
this one, yes, like recreates basically all the different types of edge cases that you'd have over in the actual level geometry, so that you can more specifically isolate the issues and properly debug it. Because this is gorgeous, but there's a reason why these kind of things are worked in test spaces and gray boxes rather than in fully fledged, visually designed levels.
Yeah, these were actually this testing level was created after the forest scene, and it was created because some customers reported issues on a specific combinations of colliders. So I wanted to quickly simulate, for example, there were 2 mesh colliders combined with 1 box collider under some slope. So that was easy for me to find the specific case and quickly simulate and fix the problem on the character controller. Yeah.
Great. I think, you know, we mentioned that a bit of passing, but with the level, with the shots, with the weapons, with the players, a big part was, of course, performance. And how did we go about, you know, investigating, okay, what are the bottlenecks, which are the piece of code that we actually need to optimize? Like, did we have something special, or is there some, you know, general procedure that you can recommend as well to our audience here as to how they should proceed when they go about doing these optimizations in their own game?
General rule is just spawn a lot of objects and see how it looks in Profiler. That's basically all you need.
That's all.
Yeah.
So, you know, everybody can achieve that.
Great.
Yeah, it depends. For example, the KCC is easier to debug because the logic runs every frame. The other case is, for example, a projectile which spawns a big explosion, and this explosion affects other objects and spread the execution logic. And this happens, for example, in 1 frame per several seconds. So this is harder to find and debug because you need to analyze the whole call stack and see which basically part causes the spike. Yeah.
And so what were some of the, you know, most surprising bottlenecks that you had to investigate?
I don't really know.
Nothing. Everything was easy.
Yeah, exactly. You know.
No. If I may, I comment to optimizations and finding bottlenecks. I think it comes down to having good testing environment, having tests, and being able to stress test it with a lot of players, which is not really easy to do if you are targeting 200 players. And I think he is very good at it. He always goes above and beyond when testing things. So he creates tools to help him, etc. Maybe you can talk about it a little bit.
Yeah, so I have simple scripts which spawn dedicated server plus batch clients. So I have spawned 20 processes. Each process handle 10 clients, which connects to a single server. And all this runs on 3 machines. So 1 machine is dedicated for the server, So there's no other logic running which could affect the performance of the process. And other two machines are running clients. That's the whole setup needed to run 200 players. There are also some optimizations needed for clients, because running 10 or 100 clients per machine is not realistic if you spawn all the graphics and so on. So the first part was to run it in batch mode, so no renders are executed, there's no audio running, and you also don't have to run some logic in the game. The only what you need is to generate some input for the dedicated server. So yeah.
So yes, this means that the way you went about testing here is not just like your regular unit test that you could be writing in Unity.
Mm-hmm.
Is it?
Yeah.
If when we had the first public test, it was from my perspective, it was kind of disaster. We had this test where that it was everything was working fine, but then dozens of people started to join and especially disconnect and leave, etc. And things got broken, and we were like, okay, we need better test. And that's the time I think UG was like, okay, we need to stress test it with many players reconnecting, etc. So this was kind of opening eyes moment where the first public playtest where you could spawn a different weapon, and every 20 minutes the server crashed because we had some stupid bug there. So
I mean, that's why you do public tests, because you need a scale, right? Like there's only so much that you can do using synthetic tests. And I think this is also, as a matter of fact, a big reason why you, like the audience, also should consider, especially if you're doing a multiplayer game, finding kind of like a closed community among your target audience that can do real life tests, because players will always find a way to do things that you either didn't think about, thought impossible, or thought have had prevented already.
Yeah. And they're playing on different computers, like even problem that we haven't thought about, that someone would run it on such a potato PC that it would load the map that we will talk about further, like for a minute or something, and we were like, okay, we need to take care of this case as well. So so after this first playtest, we kind of scratched part of the code that handled players basically and made it much more robust. So the reconnecting, disconnecting would work much better.
Yeah, and if I can add something, I think it's always good if you can test your game by quantity. Let's say constantly getting the game spawned, randomly joining, leaving players, and just repeatedly letting it trying it to break. This is one feature I'm actually missing from Quantum, because when we were testing the Quantum FPS, I just spawned a lot of games in memory, simulated some input, and it was running headless without Unity and just simulating thousands of games in minutes or hours.
Yeah. This is actually one of the, I remember when that came out, you had also written a really, really neat tool to have basically hundreds and hundreds of bots not only play against each other, but literally walk all aspects of the map to see whether there was anything broken in it.
Yes.
And that was like, as you said, I seem to remember you said something like you could run 200 matches in about 10 seconds because it was just a C#
yes
application, right? So there are ways, but again, the more you test and the more you test at scale, the harder it becomes and the more specialty knowledge you require.
Yeah.
So that is why getting your community in early allows you to kind of sidestep this a little bit by having actual human beings, provide some of the inputs. That is also much more random than a bot would ever be.
Yeah.
Right. So we have most of the core features of the game here in their initial form discussed, but there's of course one aspect that we have not, and that I'm sure everybody else here on the stream is curious about, and that is, what about the animations? Because you on one hand animate the character, but on the other hand, as some of you might have noticed, if by playing or by looking at the sample, the crosshair does as well and moves around. So we're talking about character animation and recoil. Which one do you guys want to tackle first?
I think we will tackle recoil first because it's the easier one. Easier one in the closet. So for the recoil, there are multiple ways how you can tackle that. You can either move directly with the user input, like the crosshair. You can have static crosshair, but the weapon goes up. There are multiple ways, and we chose I believe it's more like a Counter-Strike way, where when you fire a weapon, the weapon goes up and you can fight against it. And it follows recoil patterns that we had in the game quite early on. And it's just a setup that you will basically create a dots, like a trail of where each bullet should land. And when you are shooting, it just follows this pattern. It can restart the pattern when you don't fire for some time, or it can continue the pattern. There is some logic around it, and that was the recoil. With that, it comes the recoil reduction, which was a feature that I really wanted to. So be able to fight against the recoil, and then the crosshair would basically stay on the spot. So we had that there. It actually wasn't that problematic as I thought it would be. Just one math function to do that. Yeah, so that was the recoil. I think we have a video about recoil here. Maybe I can upload it.
Oh yeah, you can.
Let's.
Okay, let's do this. I will try. So that was basically the initial state of the game, with some basic recoil pattern for weapons. As you can see, it always starts the pattern from the start, and it goes. Here is the showcase of the recoil reduction, where you fight against it. It is. We should definitely say that we do not only have the recoils that influence the bullets, but also we have dispersion that is applied on top. So the weapon starts really precise from start, but then it gets less and less precise based on the settings for every weapon. And we had a lot of the weapons initially. Actually, there was a shotgun, 2 pistols, SMGs, multiple rifles,
crossbow.
Yeah, so there were a lot of games, a lot of weapons, and we kind of had to strip it. I'm sure we will talk about assets later on. It was shame as well, because we had a lot of work into it. Even balancing weapons was, I think for us, I actually had an Excel sprite sheet with custom functions that would calculate damage per second in that sprite sheet, and I balanced weapons there. But it's all gone. There are only 3 weapons there, and it's up to the users to add more. So that's about recoil and partially weapons. Jiri, animation is yours.
Yeah, so I will continue with animations. So the first requirement for the animation is, as always, performance. Running 200 players, 60 hertz on the server is simply not possible with a classic mechanism because it takes too much power, too much CPU. On the client, it's not that much a problem because you see, for example, only 20 players at max. Rest are just occluded and it's just fine. On the server, all characters needs to be simulated, so all 200 players are active all the time and evaluated. So for this, we selected Playable's API and built our custom animation controller on top of it. And yeah, so that's for animations.
Maybe if I may comment the animations, the animations were quite a difficult thing to set up, right? Easy.
Yeah, it's very programmer centric.
It's very, very programmer centric. When
Yeah.
I joined the project, there were already some animations, and I was like, "What is this?" And this is the cost for building a tick accurate animation system and not having, I don't know, quarter of a year to build the tooling around it. So it is there in this state, and we know it's not probably most usable as it can be. But it was quite difficult already to pull it off, right?
Yes.
So the core is there, the tooling.
Yeah, we don't have much editor support, so. But
so yeah, I think
on the other end, it's really fast, and it has some really cool features. For example, the interlaced evaluation. So when, for example, 50 players join the game, every character is evaluated all the time. But when more players start joining, for example, you have 100 character, you can select the character is evaluated only once per 2 frames or 3 frames, and this way you can scale down the evaluation to, for example, 15 hertz and save more CPU. It depends how complicated is the animation controller graph. And yeah, depends how many layers and states you have, so you can fine tune how much precision you sacrifice and for example save the performance for other gameplay elements. Yeah,
well, I mean, I think at this point it's also I'm sure something worth mentioning that we, like, more importantly, why did we put so much emphasis on animation, right? Like, if you were building some of the more traditional and still very, very popular shooters, they don't worry about it as much. And that is leading back to the way we shoot, and more specifically, the way we get hit.
Yeah.
So
the tick accurate animations, what it means, have we actually talked about it?
No, we have not yet. Actually, and that's exactly what I wanted to get to. Why we put so much emphasis on having this high performance, very accurate animation system, and how it ties into, well, the shooting gameplay, and more specifically the hitboxes that, well, you're trying to aim for as a player.
Yeah, so first let's discuss what the tick accurate animations mean actually. So it means that when running simulation in Fusion, the animation state is part of the simulation tick and can be just returned back or resimulated however we like. So animations are same on all clients and the server at the same tick. which is important part for lack compensated hits or precise hits. So that was the reason we wanted to have the 100% tick accuracy on the shooting. So this is the way that why you need to do tick accurate animations. And not sure if I should mention a little bit how lag compensation works actually, but what do you think, Tim?
I mean, anybody using Fusion has likely already an idea, but
Yeah.
elaborate on a bit on how you leverage that for this perfect shooting in combination with animation. I think that is going to be helpful for everybody.
Do you want to take this answer, Jiri, or should I?
No, you can answer.
Okay. So for the lag compensation, how it works is basically every client and server has this lag compensated hit buffer where it saves the position of the hitboxes. Hitboxes are just a special colliders that are on the main character body, right? Character parts. So you have special hitbox for head, special hitbox for chest, special for legs, and in BR200 we have this inherited a little bit to special body parts, which also has like damage multipliers. So if you hit someone in the head, it's like double the damage than what you would get when you hit him in the leg. So we have this body part. And how the lag compensation works is that on every client, in the forward tick of the simulation, it saves the positions of the hitboxes. So, for example, for tick 100, you have the hitboxes in certain position, and with the tick accurate animations, we actually guarantee that the positions are on all clients and the server are the same. So when you when you fire a weapon, you hit someone in tick 100, it travels to the server. Server has the same buffer of hits as anyone else, and it simply knows when you actually shot the weapon. It was in the tick 100, and it knows what was your interpolated time, basically. Sorry, I forgot to totally mention that on clients you are in two times. You are in a predicted time, which is you as the local player, and there are in snapshot interpolated time, which we call also remote time. Which is interpolation between server ticks that you already received and are verified, basically. So you see the other players, the proxy players, you see a little bit behind in time in terms of your own predicted timing. And when your hit in that tick actually arrives to the server, it knows, hey, you shot at tick 100, but actually you saw other players at tick 95. So it actually makes the shot against the colliders in the tick 95. And it can go even beyond. It can know that you were actually in the middle of the ticks. For example, you had the tick 94 and 97, and the proxies were interpolating between them. That's what we call sub-tick accuracy in terms of lag compensation. That actually it interpolates on server, it interpolates the hitbox colliders to that precise position that you saw on the client, and you are shooting against that. So I actually made it a little bit more deeper than I thought I would, so I hope.
No, it's all good. I think it's like just to kind of dig in just a little bit more into sub-tick accurate lag compensation. So we know that the network simulation rate is at 60 hertz, right? But as we all know, this is a fixed update rate. It is completely decoupled from the rendering rate. And so especially in competitive games, which are, esports title, that tend to be very lightweight and can render at hundreds of frames per second, you need that extra information if you want somebody, who has a higher refresh rate to actually feel that the game is responsive and that, the frame that they shot on from their point of view is actually the frame that they landed the hit in, if they did so.
Yeah, in here it's worth to mention that you can take it even further with the subject accuracy, and that is because currently when we process inputs like a fire input, we do it basically tick aligned. We process the fire input as soon as next tick as soon as next tick after your render input is processed. So you can make it even further, basically record when between the ticks you actually pull the trigger, and you can use this value between ticks as alpha to put it inside the luck compensation cast. So you can actually make it even further sub-tick accurate, because you would even track between the simulation the inputs, which is currently kept at 60 hertz for VR. I do not want to go too deep into this topic because it's super advanced and it is controversial even inside Photon. So yeah.
So, all right. I mean, now we've basically covered all the fundamentals that make up the actual, core aspects of BR200. And those are absolutely essential in order to, have something that you can build out on, and then, of course, make it and share it with others. So based on, these early stages that we had, where did we go from there afterwards to make it into something that we could share first with, our circle customers in an advanced version, and then later down the road, the version that we have released now? What were the things that we wanted to add in terms of, whether it's gameplay or network capabilities as far as the Fusion SDK is concerned?
I'm not sure what you're asking for.
I mean, so right now, we had the weapons that we had, the characters.
Oh yeah.
But of course, there's all the elements regarding the UI, the rounds, the gameplay that still had to be added. Like, for instance,
Yes.
The platforms that are very, very cool, but also very, very hard to implement in multiplayer, as we all know too well. So what was the process after we had this solid version that okay, cool, now let's bring it up a step to make it releasable?
Yeah, so the next step was to bring actual 200 players into a level. So we started to iterate on a new map. Can you show my screen?
Yes, I can.
So we can show a few screenshots. So that was a new level, which was big enough to have a lot of people inside. There were few places or several places where the players can spawn and pick up weapons. So yeah, you can see it's quite a big map. So
what was the size, you see?
It was 1.5 kilometers per 1.5 kilometer, something like that.
So we kind of were over the top with the map size.
It was really big. Originally we used a Vegetation Studio plugin from the asset store to quickly spawn the trees and all the biomes on the terrain, which in the end was also not good because it was performance heavy for such a big map. But it was working for us. We were able to run public tests on this map, and I was able to spawn more clients. I was already spawning 200 clients on this map to simulate a more real scenario. And yeah, so I think we can play the video to show.
Right.
And we were also iterating on more gameplay elements like the item boxes. You can see the jetpack for the first time here. And yeah, we were building the user
Yeah.
interface,
If
shrinking areas.
if I may, a story, since it is Postmortem, how the jetpack actually was created. It was basically when I worked something with the models, and I saw like, hey, there is a cool model for jetpack for this asset, and I was like, okay, let's try to do that. I also wanted to check how the processors for the KCC that Jiri made work. So the jetpack is just another processor in the pipeline of the KCC, and it worked actually really well, and I was surprised with that, and that's how we got the jetpack. I actually never haven't told anyone that it's there or something, and then I think it was the first playtest that people are like, oh my god, what is this? And start using that. And I never thought we will keep it there, but it kind of stuck there too.
Well, I mean, there's a general rule in game development is if you can put in a jetpack, it's always better. There's there are very, very few games in this world that are not more fun with jetpacks.
Yeah.
That is one of the rules.
Okay. Yeah. So the next step was to build something which is also good for public playtesting, and this is the UI. So Jirka did a really good job on iterating all the stuff, making all the menus, all the graphics for the game, and yeah. So
yeah, it was the time when we wanted to have some kind of server browser to easily test the game and start the levels. So we just put together this simple UI and simple menu, and that was the start of the proper playtest, I would say. So.
And then the release came in, I mean, for the circle members, and we started thinking about how to optimize the project, shrink the assets we needed, and so on. And because these visuals, these forest assets were too big, it was slowing us down a bit. The builds were taking a lot. Also, the process for testing were taking a lot of memory. So we decided to strip as much assets as possible, keeping it simple. And yeah, we created.
Sorry.
We created. I think it's fine to show the generated levels.
No, I didn't know Tim is sharing it, so I didn't want to interrupt. Sorry.
Yeah, no problem. You can advance with the generated levels.
Yeah. So with the size, huge size of the map that Jiri was working on, like the 1.6 kilometer by 1.6 kilometer, the gameplay wasn't really there. Like we didn't have the capacity to
make a proper game design and
make this map basically interesting. We are not designers or graphic guys, so we decided to eventually strip this map and try a different approach. And there's where the level generation came in. We actually thought that, hey, we will just generate the map with with some verticality, with some hideouts like boxes or something. It will probably turn out better in terms of gameplay than the hollow map that we had in the forest, even though it will be kind of a proper prototype graphics, you can see that it's mostly like a default pro builder texture, etc. But I think it eventually worked really well for us, because we could all of the sudden we could generate maps from really small ones up to the really large ones for those 200 players.
And I mean, as you mentioned, like the main reason here was not performance in terms of at runtime, but really build performance. So, you know, you could have totally these massive, really detailed maps if you have the time to build it. But as we wanted to hand this to, well, you developers to be able to quickly iterate and build stuff and test stuff, we had to keep in mind, okay, how much time will it actually take for you to run a build? And so, yeah, just to be clear, like you can have the most detailed maps with 4K res and 8K weapons if you so desire. But of course, that will mean that your build time is larger accordingly. For this kind of project, it just was less useful than having something that was serviceable and that showcased everything that you needed to know that was relevant to the actual networking simulation itself.
Yeah, of course, the build time and build size is also relevant, but you of course need to have the manpower to pull off such a large level, not just in terms of assets, but even in terms of the asset placement. It is just so much space that you need to fill in, and then come a whole another thing like render optimizations. So it is quite a lot of work.
I think at this point, if you allow me, I'd love to also mention, like, we are a company that is made of engineers by engineers and that solves tech issues. So while we have all a sense of design, Jirka being one of those that has even some artistic capabilities compared to a lot of us, we really relied on other creators from the Unity space to bring our project to life. And so all the assets that you see in this project are things that are available on the asset store for you to purchase from the original creators if you want the full packs for your own projects. So, you know, it looks so good because we built the tech and others helped us with the visuals. So feel free to give them some love and check out what they are offering.
Exactly. So we ended up with this level generation. I'm not sure if I should mention how we came to that or how we built it.
Go ahead.
Yeah.
I mean, that's what we're here for.
Okay. So this was done by me, and I must say I really enjoyed working on that. It was quite fast. I think the main concepts or the version that you see here is like 2 days of work, and I created all those towers, etc. in ProBuilder. And the core concept is this: you have some kind of areas randomly spawned around the square map. Those are the colored ones you see in this image. It's like a red, green, and blue area. You can have as many areas as you would like. So we are using it that in the smallest map you have just two towers, 2 areas, and in the largest you have 7. And then there is some like noise values that will say how high the area is and where it is placed. And from that we build this area down to the coasts, which are the gray ones, and then there is only the water. It is built from blocks. There's this large one. So it is built from these blocks, basically, which are prefabricated, pre-made. And every block is actually, you see the blue wire spheres. Those are places that show how high the block is in that area. And this is where we connect the blocks with what I call connectors. And the connector could be anything from a ramp to pile of boxes to stairs. There is this like staircase, etc. So this is the way how we connect those tiles together. That's basically just it. I think this approach of having the prefabricated things and then connect it randomly with some connectors, it helps to not have the map really too repetitive. Because on every block the connector is somewhat different, and sometimes the connector looks like the block, so it breaks your concept that it is just blocks, like prefabricated blocks. So yeah, that's how it works.
Very cool. I mean, that's the first time I see those pictures myself. So that's really cool to see a bit more under the hood. Even though I've been part of the process, there's still aspects I have not seen up until well, actually up until this very stream. So
maybe if I may comment, actually Jiri asked me about this today as well. You can see that there are these white spheres. Those are possible spawn points for the player. There are also points that actually mark where the item boxes could spawn, and it is also randomized somehow. And what Jiri asked me is how the connectors actually work, how they connect the prefabricated blocks. Well, it is like that. You have block with the blue sphere on the side, and then you have next to it another block. You know what is the height difference between those four blue spheres, and I have setup for the connectors where they like, okay, this connector can be used from heights 5 up to 10, and so it is then randomly chosen. And if the height of the blue spheres is actually uneven on one side, it knows that it should use only half connector, not the full ones, which is, for example, ramp alongside the whole side of the block. So there are some pools of connectors that it can choose from, and that's how it's done.
Pretty cool. And well, okay, so we have a quick question here. Whether you were the two only ones working on the project. Well, we had a third one, Tomasz, which is today not on stream with us. But was there anybody else that worked on the project? I think it was the three of you, wasn't it?
Yeah.
Except the whole Fusion team. Who cares for the Fusion SDK?
Right. So this is actually, yes, I mean, that goes, thank you. That goes without saying, but it's actually also a perfect jumping off point for mentioning, like, we built this project to show, you know, what was possible and what is achievable in real life with AAA resources, but also it was basically a test of, okay, can Fusion reach those things? That means the reason why this project started during the very early stages of Fusion is so that we could make improvements to the SDK that would enable these kind of games at this scale with these type of player counts and this performance. So yes, of course, I mean, the whole team aided by improving the SDK when you found pieces. And I mean, that is how it should be, right?
And this project also served for us like a battle testing ground. So when we started this project, especially when Jiri started, the Fusion was still in beta, I think, right? Jiri?
Alpha. That was 18 months ago.
Yeah, it was alpha.
18.
So during the development of this project, the Fusion also evolved, and many of the things we struggled in with this project were then fixed in the Fusion SDK. So you guys, you participants of the stream, don't have to deal with it anymore. So it was also what took time, basically, when building this, because when we struggled with I don't know, some network calling issues, it was time to investigate it, and it sometimes took a lot of time to find a proper solution, maybe go around it, and it got into the Fusion SDK, I don't know, some time later, and then we need to again remove the functionality. So it was kind of a back and forth process.
I mean, it was a net positive result, right? Like, I mean, without finding those issues, we wouldn't have been able to make the improvements that then help improve the project overall. I mean, that goes with any, I mean, that's the luxury, right, of game development, so to speak. Everybody thinks, oh, you play all these games. You go like, yes, we play a lot of broken games so that we can fix them so that the end product is good and stable. That is the same with tech and any other aspect of game development. So yes, that's a very good point to highlight.
Okay. So I think next thing is a separation of fusion projectiles, which is different project and which evolved from this sample.
Yeah, so
I think we can play the video. I will upload.
Yes, please do.
And then Jirka can comment because he is leading that behind this sample.
Yeah, leading and only. So I'm leading myself. So where this idea for separate projectile sample came up, it was when we worked on the BR, and we had this hit scan weapons, and then we wanted to make there some kind of kinematic projectiles, like arrow that flies through the air and is falling down, or grenades, and we do have them there, but those are like since they are slow and not really frequent, we actually spawn separate network objects for them. So it's not really performant option if you would like to spawn hundreds of those projectiles per minute. So, and it wasn't really needed in the BR, and I wanted to have this sample project that basically is like BR, the quality of code that is in BR, the performance and everything, but that would also incorporate these other types of projectiles, and it would actually work. It was also a playground where we could test the advanced topics of projectiles that actually aren't really in the BR. For example, the visuals interpolation between the visual path from barrel of the weapon to the actual path that is being simulated from the center of camera. That is, for example, not the part of the BR, because it's not really needed there. It could be there just for the grenades, but it isn't worth to make the code more complex just for the grenades. So there it is faked a little bit. With this projectile project, it took it a little further. Like even the management of the projectiles is a little bit more sophisticated, and yeah, that's it.
I think this is a very good point also to kind of remember that projectiles is like in shooting in general, anything that is a moving part, there's like, yes, in multiplayer there's a lot of smoke and mirrors, because I mean in the past hit scan weapons were like the way to do things because of bandwidth, but nowadays, and you show that perfectly in the sample, is like projectiles can come in many different shapes and forms, both literally and figuratively, depending on your gameplay. But depending on what you need for your gameplay, that does have performance costs that have to be accounted for. So, you know, play, test, and as usual, decide based on your design, not based on the tech for these kind of things.
Yeah, my recommendation would definitely be to start just with the hit scan weapons. It feels snappy. It's really low bandwidth, and it's much easier, like magnitude easier than when you need to tackle the kinematic projectiles correctly. I mean, the kinematic projectiles that you need to shoot hundreds times a minute, for example, so with high cadence. That's what the projectile sample shows. it can be complex at times, which is what some users are complaining about, and I hear that. I definitely plan to have their basic section just to showcase the basics, to have the simple hit scan buffer or the simple projectile buffer with the hit scan projectiles. Because when you are doing hit scan projectiles, you don't need any visuals interpolation, because you can instantly showcase the visual, or you know where the bullet is landing. That's the most important part. You know where the bullet is landing, so you can move the visuals from the barrel of the gun to that point without issues, because it is known, the path of the projectile is known. And you can have like flying projectiles, which is what we have in VR. Basically, you shoot the bullet, the hit scan cast instantly. You have instant hit to the body of the player, but you will showcase the dummy visual projectile that is actually flying through the air. That's not an issue with the hit scan. You can still have this flying feeling, but the hits are instant.
Yeah. All right. So we really covered everything as far as this development of the project, from, you know, its infancy when it was still about Vikings, over to this high-res, incredibly gorgeous and lush environment, towards the performance piece that we have now, and it has a more slimmed down visual aspect to really highlight the underlying tech, but still brought to life thanks to other creators. And is there anything else about, you know, this part of the development process you feel you'd like to add?
I think at this point we were ready to start some publishing process, but I think, Tim, you can talk more about our partnership with Unity and the final step.
Right. Well, so here's what I can say about it. Yeah, Jirka.
If I may, even before the Unity stepped in, maybe there was this whole struggle of the assets and licensing. Maybe.
Well, I mean, yes, but that's true for really any project. You have to get the right licenses, make the right partnerships to get the visuals. Well, that is a big part. I wouldn't really contribute that to the development of the gameplay itself for the most part.
Yeah, it's important for the project that we then needed to basically strip the parts of the game, right? To
we needed to make it sure that
animations, etc. So as a postmortem, it's worth mentioning how much time we actually killed by replacing assets, replacing animations.
Yeah, I mean, of course, anything that has to do with the visuals is always a big part, and us as you know, tech people tend to think about that after the fact. So it is very time consuming. It would have been easier if we thought about specific aspects of it at the very beginning, but I would say that is probably true for any given aspect that ties tech, gameplay, and then its visual feedback. But of course, you know, we have this absolute fantastic project, which a lot of you have seen for over a year already. And then it echoed very well within, you know, the realms that we move in game development, especially among the Unity realm. And therefore we thought, okay, you know, let's extend that even further, because if you want to do something competitive grade and AAA, you want to host the actual game session on dedicated servers. But of course, we don't host dedicated game session servers. And that's where multiplayer came in. However, we won't be talking about it today. We will be talking about it next week, when one of the lead devs over at Multiplay joins us for a special session of Photon Insiders, where we will then talk about exactly what it took to integrate Multiplay and the matchmaker to get the orchestration and the actual matchmaking going in Fusion BR, and have it, the product that you now have in your hands. Well, figuratively speaking, it's very hard to get your hands on the actual physical asset since it's digital, but you get my drift. Now, important part is here, of course, is that this project at this stage, it was finished. It was client server, it could be player hosted, it could already run on a dedicated service. But of course, just because it could doesn't mean that it's obvious how it should. And so through this partnership, we were able to show you how to integrate with one such service and therefore illustrate the path that you could take moving forward. And as I said, next week on Photon Insiders, we'll dive into this very topic. So then,
Okay.
I think we've got everything covered at this point. And is there any last words that either of you would like to say to our beloved stream here?
I will just add, if you want to see, let's say, more technical details, a lot of stuff are missing in this live stream, but it is covered by documentation on our web pages. So if you want to see, let's say, some details on area of interest and some optimizations, there are some interesting topics which we described.
That is a very good point. Like, of course, in the stream, we have only been able to tackle the major points, but there's so much more in the sample. And there's the documentation of it, there's all the comments in the code, and then there is the code base itself. So, grab it off the asset store, dig into it, learn, and build the next awesome Battle Royale game for all of us to play.
And give us feedback.
Yes, of course. All right.
Okay.
Jiri, anything on Jirka, anything on your end?
No, enjoy the project.
We mostly had fun building it. There were some tough times, like in any piece of development, but I think the results speak for itself. So thank you very much, Jiri and Jirka, for joining today's Photon Insider stream. Thank you for tuning in. And as I said, next week we got more. And on Friday, we have something more for the multiplayer game jam. So make sure to tune in then as well if you're currently jamming alongside all the other devs. Thank you very much for joining today. And I wish you all a great evening.
Thank you. Bye.
Bye.